But then we'll start 4.6 part 2. So we taught you one tactic yesterday, and that tactic was being able to cancel out the bases of exponents if they were the same number. So that's like tactic number 1 of how to solve exponential or log functions. A second one is what I'm going to show you now. So we always like to do that tactic number 1. So we always check to see, can I do that thing where my bases equal the same thing so I can cancel them out and set my exponents equal to one another? So let's check, would that be possible here? Can I make 4 into 11 or 11 into 4? Sure. Yeah, it's not, like you're all like giving me that look like, no, of course not, don't be silly. It can't happen. So we cannot use the tactic we did yesterday, right? Like that cannot be done. So instead we have to like hit the drawing board again and think of something new. So I want to remind you of the property that is log base b of b. If you have the same base as what you're taking that log of, those cancel and it just equals your exponent, right? You guys remember that one? All right, yeah, I'll take the questions. So I can use that here, right? I don't want to multiply by something. I don't want to divide by something. I want to try to add something in to cancel out the 4. Why am I trying to cancel out the 4? I need to get this x out of my exponent in order to solve this function. So if I add in a log, it feels a little weird, but this is something that you can do. You can add in a log as long as you do it to both sides, right? It's legal if I divide by a number as long as I do it to both sides. It's okay for me to multiply by a number as long as I do it to both sides. I can square root both sides, take both sides to an exponent. I can subtract, add, I can do anything I want as long as I do it to both sides. What kind of a base does this log need to be though for this to help me? Yeah, log base 4. Why'd you say 4?
Because if you need to cancel them out, they have to be the same number.
Very good. If I want to
I can't see nothing, the glare.
if you from this one.
Yeah.
If you want to cancel out, is that better? Okay. If you want to cancel out this number, the base has to be the same of that number. And again, I'm choosing 4 and not 11 because the exponent is in my, or the variable's in my exponent on this side. So I need to get rid of that 4. The 11, like, I don't really care about that. I'm fine with it. So both sides has to be a log base 4. Then we know log base 4 and 4 cancel each other out, right? So I get x equals log base 4 of 11. Did I solve for x? Yeah. Does it look like a nice, clean, fun number? Like, is this just like a x equals 2 and I'm done?
No.
No. This answer is a really weird answer, but I could find the decimal if I wanted to, right? I'm okay with you leaving it this way. Actually, I want to see your log answer. If this like drives you absolutely insane, you're like, I want to find this decimal. I want to figure out what that is in my calculator. You can do so, but I do want to see your log answer before that. So remember, if you want to put this into your calculator, since it's not a base 10, you have to go to math and all the way down to log capital base in order to do this. So math.
This isn't required, but you want us to do this?
It's okay. If you leave it like this, I'm okay with it. Okay. Keep in mind, this is going to start to get as really gross numbers that way. So log base 4 of 11 will be 1.729. So again, this answer is okay, but if you took me from here to here, I may not know what happened in between. And if you get a wrong answer, I'm going to have to give you more points off because I didn't see your answer in between. If you give me this in a wrong decimal, I'll be like, ooh, that's okay. I'll still give it to you. Okay, so either of these answers is okay.
So we don't need to find the
No, that's okay. You don't need to. There's another part in the test that I'll have you find this decimal like in your calculator, so I don't need to see you do it more than once. Questions? Feels a little weird, right? Adding in a log to solve this.
Oh,
Let's do another one. So let's solve, this is likely gonna work out pretty gross. Let's solve 1 plus 7 to the x plus 2 equals 3. Okay, so we enhance this a little bit, like we took a big step up. So when we go to solve any kind of function for x, you automatically are just trying to isolate x as much as possible, right? If I had like 2 plus 3x equals 5, what's the first thing that you would get rid of?
the 2 plus 3.
Good, the 2. You want to get rid of this 2 first, because you start working with the farthest away from x and then start getting rid of the closer away from x. So in this function then, thinking in that same way, what's the first thing I'm going to get rid of?
So
The 1, good.
the 1.
The furthest thing away from x is this 1.
Just subtract that from 3.
Good, because I don't want to get rid of the 7 yet. That's closer to x, and the 2 is the closest to x, so get rid of the 1 first. Giving me 7 to the x plus 2 equals 2. Now what do I need to do?
Now we need to solve. No?
Good, yeah, keep solving. How do I keep solving? I want to get rid of the 7,
You wanna get rid of that 2.
get rid of the 7.
7, yeah, I do that.
How can I get rid of the 7?
And it can't be negative either, can it?
No, what did we just talk about in the last example? What can I add in?
Log,
Good. What kind of base?
base 4, 3, no, 3.
7, good.
I knew that.
Log base 7. Is it log base 2 on this side?
No, that's what I'm saying,
Good, has to be the same.
yeah.
So now log base 7 and 7 cancel to give me x plus 2 equals log base 7 of 2. Still need to solve. Before you go on to the next step, tell me, can I take 3x minus 2 and that would equal, I don't know if you can see that. If I took 3x minus 2, would this equal x? Does it? Yeah, why not? So can I, like if I took this, can I take 2 away from 3x? Basically is what I'm saying.
No,
Why not?
because they don't go into each other.
Right, they don't go into each other, they're not like terms. So you cannot subtract something from something that's not a like term. So tell me, when I go to subtract this 2 next, is 2 and a log base 7 of 2 a like term?
No.
No, so will I take 2 minus 2 and make it 0?
No.
No, good, I'm just getting ahead of the mistakes that I know I always see. So this will be instead x equals log base 7 of 2, and I'm gonna put that in parentheses, minus 2, because I promise you, you're gonna put that into your calculator and mess that one up if you do choose to put this into your calculator. A lot of the times, like I would see, okay, well, I'm gonna take log base 2 of 0 then, or log base 7 of 0, because the 2 minus the 2 makes 0, right? Keep in mind that this is in itself a quantity, and then you have to subtract 2 from that. Questions on any of this?
That one I kind of understood.
Good, you guys are kind of rocking and rolling on this. Okay, I want to leave this example up so that we can compare it to the next one. So while logs are a thing, natural log is also a thing, right?
Yeah.
What kind of a base is natural log? It's log base
Base.
E. Good. Natural log is log base E. There we go. Okay. So we have to keep that in mind for this next example. I want us to solve one, let's do a -1, plus e to the x equals 7. Yeah, that's good. Okay, again, start furthest away from my x. What am I gonna get rid of?
And -1.
Good, we're gonna add 1. E to the x equals 8. Now I'm at that stage where I have to get rid of the base of my exponent, right? I had to get rid of the 7 by taking a log base 7. So if I want to get rid of an e, you have to get rid of that by taking,
You have to, it's by taking negative.
good, log base e. And what is log base e?
A natural log.
Good, so if I add a natural log to both sides, that is natural log of e to the x equals natural log of 8. So because of the fact that this technically is log base e of e to the x equals log base e of 8, what happens to my natural log in e?
It goes away.
Shazam, good, they go away to get x equals natural log of 8. Right, and you know how to put that in your calculator. That's actually right on your front screen, directly underneath that log button. You could do a really quick natural log of 8. It equals 2.07 if you'd like to. How's this one? Are you okay with it? If the thought process of it doesn't look quite as clean, like this is like 7, bam, gone. And this is like an ln and an e. Why is that happening? But always refer back to the fact that natural log does equal log base e. Do you guys want another example of something like this? You want to move on to tactic number 3, the last tactic.
One more?
Okay, let's do one more. I agree with one more. Do you want a number or e?
E.
Anybody else?
Yeah.
I can give 2 and you can do either of them, if that's what you want. Okay, let's do one of each. Why not? So you can do both or whatever one feels right. Let's do 5 plus, what do I want? 5 plus 3 to the 2x minus 1 equals 8. 7. There we go. 7. I like that one. That's the number version. And if you would rather do the e, 2 plus 2e to the x plus 1 equals 6.
So these are both going to be that's
Yeah, that same tactic that we
natural
just,
log.
only one will be natural log because only
And
one
that's
has
the
e.
second one, right?
Yep, good. So choose either or choose both. I'm gonna do both of them really quick. I'll probably just start solving them as soon as everyone has the one written down if they want to. You're more than welcome to talk to each other. It always feels like a Monday in this class. Like every morning, just feels like a Monday in here. You guys are like exhausted and tired. Okay, so here's both of your solutions. So in this first one, again, start furthest away from your x. We need to get rid of the 5. Once the 5 was gone, we're at that place where our base of our exponent is isolated. So then we need to cancel it out. A log base 3 will cancel out this 3, so that's added on to both sides. Exponent drops down, and then from there, it's just solving for x. So while these parentheses are not like proper use, you don't have, like, parentheses don't necessarily need to be there. It's me showing you that you cannot simplify that. Like, that's separate from the +1 and separate from the divided by 2. Okay, so this would be that final answer.
I might just be being dumb.
No, you're fine.
The one that says 2x equals log 3 to 2.
This
and
one?
in parentheses- No, down 1. Why is the 1 over there?
Over here.
Shouldn't it be right here?
Oh, so I just added it over.
Oh.
That's the only reason. Yeah, good question. Good thing to clarify. Okay, so this E, yeah.
Move that down more.
So the E one, I really wanted to make sure that I got out there, so even if you didn't do this one, it would be a great one just to try, like, and just write down. Because there's one single instance that happened that you hadn't seen yet. Of course, we had to get rid of the first 2, because that's the furthest away from x in the beginning. But then we had 2e to the x plus 1. So I still have a number outside of that e. So we had to divide by 2 to get rid of that. Then I have e isolated, meaning I can take natural log of e to get that canceled out and then just solve from there. How do you feel good about your answer? Do you know how to simplify those?
Yeah, I
Okay.
stopped at like
Okay.
x plus 1.
Right, okay, that's fine, especially because like you're probably just trying to get through both of them, so that's okay. Are you guys ready for tactic number 3?
Not really.
Oh, I think you are. I totally think you are. So we're gonna keep in mind, we're practicing these all tomorrow. So you're gonna get them kind of jumbled up where you get to decide, like, what tactic do I have to use? So that will put you to the test tomorrow. I just wanna make sure that we get you through all 3 of them today. Oh yeah, we got time. Okay, the last and final 3rd tactic. So if you're kind of labeling these, I would put like tactic number 3. I don't know why I call them tactics. It makes me feel like a little FBI agent. So that was really stupid. So this one, and I'm gonna get an actual one that works out decently. This one. Oh yeah, this'll work good. This one's actually starting with a log, which makes things seem a little bit weird. We're usually the one that's been bringing that in or been avoiding having to have a log in there. So when we're starting with a log, we are going to be honing in on this property. Okay, so when you have an exponent to an x, or a base of an exponent to the exponent of a log with the same base as your exponent, they cancel. And what you took that exponent of drops down. So this is by far the weirdest, most like foreign process to you that we've done so far. So adding in a log was kind of weird enough. Like you're used to adding, subtracting, multiplying, dividing things on and off, maybe squaring, square root, but adding in a log was super odd. This one is by far the weirdest. So think about tactic number 1, getting equal bases and setting their exponents equal to one another. Is that gonna happen here?
No.
Yeah, definitely not. Think about the last tactic. We had numbers and we introduced a log to cancel out the bases of those exponents. Is that gonna work?
Yeah, no.
Do we even
Wait.
have exponents?
No.
No. So neither of those tactics will work just because we don't even have an exponent here. So the 3rd tactic is called exponentiating. So what do I need to get rid of to get x by itself?
You gotta get rid of the log.
Good. Yeah, this log base 2 needs to be gone. I can divide off a 5, but you cannot, don't try it, you cannot divide off a log. You cannot do it. So instead, I want to find a way to cancel it out. So we do this process called exponentiating, where everything goes into your exponent. What's the base of this exponent is what's important to make it this all cancel away. So if I need the same number as what's in my log base, what number has to be the base of the exponent? Good, 2. Log base 2, so I have to have a base of my exponent of 2. 2 has to be the same on both sides. Okay, so again, we took everything that was at ground level and we exponentiated it. So it's all now up in our exponent. If you cover up the 2's, you have exactly what you had before. We added in a base of 2 because 2 and log base 2 now cancel, giving us 5x equals 2 to the 3rd. What's 2 cubed? Oh, you know it. We did it yesterday.
It's a.
Yeah.
Yeah.
Let's see, someone said 8. And divide 5. X equals 8/5. How's that for weird for you? A little bit. Okay. I want to show you immediately the same thing that happens when we have a natural log. So in a new example, let's say that we had, and let's do natural log of, 2 plus natural log of
What time is this one?
x plus 1, 37, equals 3. 2 plus natural log of x plus 1 equals 3. And the worksheet tomorrow is really short too, so if there's something I need to go over on the board, we absolutely can. What's the first thing I need to get rid of?
The 2.
Good, that 2. That sucker can't be there if I'm going to be exponentiating things. So natural log of x plus 1 equals 1. Now what's my thing I need to cancel out? This is natural log of this whole quantity, so I need to get rid of the natural log. So we're at this point, or we're right here, where we need to exponentiate everything. So everything at ground level is now up in our exponent. What's going to be the base of this exponent? I know, think carefully. What's natural log? Log base e. So if it's log base e, what number needs to be down here?
Oh, that would be even.
Yeah, it'd be e. Log base e, right? So think about this as log base e of e. Those will cancel to give me x. So if natural log is log base e, e and e will give me this effect. So e and natural log cancel, leaving me with x plus 1 equals e to the first, which is just e, right? And finally, x equals e minus 1. Do you remember what e is? Is it just some random variable? It's a number, right? It's an irrational number. It's like 2.7172817. I don't know. I don't know the whole number, right? But it's an irrational number. So you could still find a decimal for this number, right? So you could put e minus 1 into a calculator and figure out what that number is. You guys doing okay? Okay. You're really quiet today. I'm worried about you. Oh yeah, one more. You're gonna finish this one off and we'll go over it tomorrow. Finish this one problem off. So let's do 1 plus 2 log base 3 of x equals 7. That looks good to me. I try to keep the numbers low for this one since we take exponents. So start at your furthest away from x, work your way in, getting rid of anything you can until you get to the exponentiating step. I'm gonna give you some.
Is there homework tonight?
Nope. Yeah, tomorrow. Yeah,
I think it's much how you said like you wanna give it like one more answer, you wanna go more example, and you just end up doing like 5.
no, I have one more example in that one particular one. Like that was tactic number 2. Then we move on to tactic number 3. Let me get out of the way really quick so you can see that. Okay, guys, have a great day.
I got the right answer, but I just put a 3 down there because you put a 2 down there. I don't
Right.
really know why.
Good. So since 2 is our base, that's what goes down there.
Oh,
So it's
okay.
3 is basically what goes down there.
Thank
All right.
Um,
Oh, actually, they're gone.